Assalamu alaikum. This is Nishat Naila Priyanka, student of Daffodil International University, Software Engineering Department, ID 201352991. Now I am going to discuss encryption and decryption process using one-time pad algorithm. For one-time pad algorithm, we have numerical representation for each of these alphabets. As example, we have 23 numerical representation for W. In encryption process, we will use the equation C is equal to P plus Q mod 26, where C is ciphertext, P is plain text, and K is key. For this process, we have taken biryani as plain text and lemon as key. I have taken a table at first, then fill the first row with the plain text, fill the second row with the numerical representation of plain text, fill the third row with the key. Here, the length of our key is less than the length of our plain text. So we will fill the rest of these two cells from first to last character of key text. So we have put L and A. Then I have filled the fourth row with the numerical representation of key. Then I have get the value of C and fill the fourth row with the values. At last we will get the ciphertext. For 14 numerical representation, our alphabet is N. In this way, we will fill the row and get our ciphertext. For decryption process, we will follow the equation P is equal to C minus K mod 20C. We have used the same ciphertext as here. At first, we have taken a table, then we have put the ciphertext at the first row, put the numerical representation of ciphertext alphabet at the second row, put the key at the third row using the same process as encryption, put the numerical representation of key at the fourth row. Then we will find the value of P and put it in the fifth row. At last we will get the plain text. For two numerical representation, our alphabet is B. In this way we will fill the row and get our plain text. So our plain text is biryani. We can say that our process was right because when we encrypted biryani we get N as ciphertext, and when we decrypt the same ciphertext we get biryani as plain text. Now I will show you this process using Java code. At first I have taken a string called alphabet where I have put in all the uppercase alphabets so that I can find the numerical representation of plain text, ciphertext, and key. In the encryption method, I have passed the plain text and key or plain text and key. Then I have initialized ciphertext, ciphertext I, which is the which is the value of C, plain text I, which is the numerical representation of plain text alphabet, key text I, which is the numerical representation of key text alphabet. Then I have changed the plain text and key to uppercase so that we can find the numerical representation using this string. Then we have processed the key. If the key length is less than the plain text length, which happened here, then we will start a for loop where I is equal to 0 and our condition is key length less than plain text length. So our loop will continue until the key length reaches to the plain text length. What we will do, then we will find the character at 0 index of key text and add it to the key. So at 0 index we have L and added it to the key. In this way we will get the full key for encryption process. Then I have taken a for loop which will start with 0, continue until it reach to the plain text length. Then I have got the numerical representation for plain text, numerical representation of key text. I have I have used the equation and get the value of C. then we will get the ciphertext. For example, if I is equal to 0, then plain text character at 0 index is B, then index of B at alphabet is 0, 1. As we are using indexing, so our value will be less 1 than the actual value. So we can see that here is 2 and we have gotten 1. Then we will use the equation and get the value of C. For example, the value of C is 14. As we are using indexing, here it will be 13. So character at 13 index of alphabet string is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That is n. Here's n. In this way, we will get the full ciphertext and return it. Now decryption method, we will pass the ciphertext and key or ciphertext and key. Initialize plain text, ciphertext I, which is the numerical representation of ciphertext alphabet, plain text I, which is the value of P, key text I, which is the numerical representation of key text alphabet. Now we will change the ciphertext and key text into uppercase so that we can find the numerical representation of ciphertext and key text using alphabet string. Now we will process the key as we have processed in encryption. Here we have also processed the key. Now I have taken a for loop which will start with 0, continue until it reaches to the ciphertext length. Then find the index of the then find the numerical representation of ciphertext, numerical representation of key text. Follow the equation and get the value of P. If P is negative, then we will add the length of alphabet to the P. Then we will get the plain text. For example, if I is equal to 0, then character at 0 index of ciphertext is N. The index of N at alphabet is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. As our index is 13, the value will be 14. Here is the numerical representation. In the same way, we will find the numerical representation of key text alphabet. Then we will follow the method, get the value of P. If the value of P is 2, then our index will be 1. So at 1 index, character of alphabet is 0, 1. That is B. It's B. In the same way, we will get the full plain text and return it. Now in the main function, now in the main method, we will get the text, the key, and get the choice of encryption or decryption. If we choose encryption, then we will show the encrypted text, otherwise we will show the plain text. If we choose the wrong option, then it will show the wrong choice. As we are running this program, our plain text was biryani. Our key was lemon. We are choosing encryption. Our ciphertext is NNEXOZN. It's NNEXOZN. Then we will use the same ciphertext for decryption, running the program again. Our key was lemon, choosing decryption, and getting biryani as plain text. In this way, we can encrypt and decrypt text using one-time fact algorithm. Thank you.